Okay, ladies and gentlemen, we continue on with the counting. And as I tried to explain before, counting actually is a very advanced process. It's not simple, and it parallels human beings' ascent from nomad existence to a fixed existence, which might include settlements, cities of this type, and counting became more important um, as the structure increased. So, at any rate, these involve poker hands, and these involve questions of how many. In other words, in how many uh, ways can you be dealt a full house, or in how many ways can you be dealt a pair, or things of this type. If the question is if the question is a how many, then the answer is a whole number. It might be 10 ways, 30 ways, a million ways, okay? If the question is what is the probability of being dealt something, then of course probability is a fraction, so it would be what we're working on now, which is the how many divided by 52, choose 5, meaning 52 card deck, choosing 5 combinations. And the reason why that would be combinations is because the order that you dealt the cards in really doesn't matter in a game of poker. All right? So these are how many questions. So the answers are going to be whole numbers, not probabilities, which would give us fractions. Okay, so let's get an understanding of what a 52 card standard poker deck would be. We have four suits of 13 cards each. So we have spades, hearts, diamonds, clubs, 13 of each. Then we have denominations. These are the numbers in each suit. So we have four suits, spades, hearts, diamonds, clubs, 13 of each, and 13 denominations and numbers in each suit, going from low to high, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. So jack, queen, king are called picture cards, so forth and so on. Okay, so we're just going to do a couple of these. I'll leave the rest for you just to give you an idea of how this type of counting is done. We're going to use a fundamental counting principle, which is event A can be done in M ways, event B can be done in N ways, and if one event has no effect on the other, in other words, independent events, then you multiply. Okay, so let's start with a few simple ones. I'll just knock off a couple of these and see what happens. So, using a standard 52 card poker deck, compute the number of possible 5 card hands. In other words, how many cards you get dealt, you don't get to pick anymore. Okay? All right. In Texas Hold'em, of course, you get you get 2 cards, and then you get to see others as you go on. It's a best 5 out of 7. I'm not talking about that. That's a little more complicated. In draw poker, what happens is you get 5 cards, and then you can turn in up to 4 cards, I think, and get others. So I'm not talking about that. I'm just talking about a 5 card hand is dealt to you. How many ways can you get the various hands? Okay, royal flush. Well, royal flush would be 10, jack, queen, king, ace of hearts, diamonds, and clubs. There are only 4. So that's an easy one. Let's do 4 of a kind. And I'm skipping, I'm just arbitrarily moving around, skipping. So let's take 4 of a kind. So that means 4 aces, 4 kings, 4 whatevers. Well, first of all, there are 13 denominations: aces, queens, kings, jacks, down to twos. So once you pick the denomination, you get all 4 of them. That's done in one way. And then you have 48 other cards. So it's 13 times 48, or 624. Now, don't forget, 52 choose 5 was 2 million, some huge number. Let's see, do I have it here? Earlier, I think I asked how many 5 card poker hands are there. Yeah. Okay, 2,598,960. So about 2.6 million. So out of those 2.6 million, only 4 of them would be a royal flush. Only 624 of them would be a 4 of a kind. So you could have 4 queens and then any one of the 48 others. 4 jacks, any one of the 48 others. 4 threes and any one of the 48 others. So you multiply that, 624. Okay, full house. Let's do a full house. A full house is 3 jacks and 2 fives, or 3 of one denomination and 2 of another. So let's first experiment. And there are 13 different denominations for our 3 cards. I could have 3 kings, 3 aces, 3 tens, 3 fours, 3 sixes. All right, so there are 13 of those. And once I pick, let's say it's going to be fives or jacks or tens, of those 4, I'm picking out 3. So it's 4 choose 3 times 13, and that would give you the number of ways of getting 3. And then on the other 2 cards, I have 12 denominations, and then 4 choose 2. I'm picking 2 of them, so I have to multiply all these up, and that gives us 3,744. You know, not that easy. Okay, 3 of a kind. Okay, let's do 3 of a kind. That's interesting. So it could be 3 jacks and then piece, as they say. So how many different denominations? Right, I have 13 denominations, right? 2s, 3s, 4s, dot, 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 jacks, queen, king, aces. So that's 13. And then once I select the denomination, I have 13 ways of doing that. 4 choose 3 would be my the number of ways I could pick 3 out of those 4, because it's 3 of a kind. And then for my 4th card, it can't be one of the ones I've already picked, so it's 48. And then for the 5th card, well, it can't be any one of these, and it can't be any of the ones I just picked, so it has to be a different denomination. There are 40, and there are 44 of those cards left. So 13 times 4 choose 3 times 48 times 44. So 54,912 different 3 of a kinds I could have. Now again, if we're talking about a probability, this would be over 52 choose 5, which is 2.6 million approximately. So I'll give you an idea of the probability or the percentage of getting dealt 3 of a kind. Okay, let's do 2 pair. So that might be 5-5, Jack-Jack, something else. Or King-King, 3-3, something else. All right, so let's pick the denominations. There are 13 denominations. I'm choosing 2, so that's 13 choose 2. So once I choose, let's say, 5s and kings, out of the 4 5s, I'm choosing 2. So 4 choose 2. And out of the 4 kings, I'm choosing 2. So that's 4 choose 2 again. And then there will be 1 slot or 5th card left. And of those, I have 44 cards left. So 13 choose 2 times 4 choose 2 times 4 choose 2 times 44. 123,552 different 2-pair hands being dealt. Okay, and again, I'm using combinations, so the order the cards are dealt does not matter. Okay, and back down, total number of 5-card hands, 52 choose 5, 2,598,960. So I didn't do all of these. You know, you can sort of look at these for yourselves. They're not all that easy. Give you an idea of the kinds of mathematics that somebody has to do in order to understand basic poker. Okay, so hope this was interesting. And if you're a Texas Hold'em player, of course, there are other things that come into effect. The cards on the turn, the cards on the flop, things of that type. So, very complicated game. All right, be well.